Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and while the trial with Sam Bankman-Fried is ongoing, no breaking news were revealed, and I'm only reporting breaking news. So for those who want to stay up to date, this is a good page, gives you a summary. And as soon as something happens, I'll cover that. The next article is about Binance, and Binance will terminate its Visa debit card service in Europe on the 20th of September. The Binance Visa card, which allowed users to convert cryptocurrencies to local currencies for buying stuff, was introduced in 2020, and approximately 1% of the Binance users are affected. And this move follows a series of challenges for Binance, including the recent issue with euro transaction and halted onboarding in the UK. Now, there is more than that. There is the following article here. Binance US has stopped US dollar withdrawal following the earlier halt that was in June of the deposits due to the SEC. And so the customers cannot withdraw US dollar anymore, and they're advised to convert them to stable coins or other cryptocurrencies and send them via blockchain. And the SEC previously sued Binance and its leadership on multiple charges, including deceptive practices and misusing customer funds. And here, I want to mention a clarification on my side. Last week, I reported about the Tor swap halt, and I was discussing this with Marcel Harman, and he pointed out that money laundering involves disguising the origin of illicit funds, for example, with a service like Tornado Cash. And in contrast to that, Torchain does not obscure anything. So while the hacked funds may switch change, the process remains fully transparent and is traceable. So this is important to recognize that Torchain shouldn't be associated with money laundering, and it even offers more tracing points because it's fully transparent. The next article is from Brian Krebs. This article here, it's about hacked websites that claim the visitors need a browser update. They use a technique called ClearFake, and they show the users simply alerts that they need to update fake browsers. And when the user click on the update prompt, it deploys malware that tries to install a data stealing Trojan horse. But recently, attackers have started hosting these malicious files on the Binance Smart Chain as a cryptocurrency transaction. And this has the advantage that you cannot actually take it down. However, you can actually block the access, or Binance can block the access to those transactions. But the files are permanently stored on the chain, and if you know how, can be accessed. But as convenience, you need a kind of a proxy which Binance offers, and in this proxy they can actually block those requests. The next article is about Bitflips, about DRAM, and it's this article here. In my spring lecture, I'm talking a lot about Bitflips, especially in the beginning of the lecture series about ECC. And since bit flips can happen, for example, due to cosmic rays, your server infrastructure that runs 24/7 should have countermeasures. However, there are also malicious ways to flip bits. That was revealed with RowHammer, and RowHammer can lead to bit flips by repeatedly accessing specific areas of your DDR memory chip. And the countermeasures were implemented. So most of the DDR4 chips, they have implemented countermeasures, and they do not allow hammering specific regions. However, a new technique has been revealed, which is called RowPress, and can cause similar issues. Even can cause those bit flips even with RowHammer protection. This RowPress method involves keeping particular DRAM rows open, while in combination with RowHammer can lead to more bit flips. And current countermeasures that work against RowHammer with this amplification with RowPress is not working. So there needs to be updates in the upcoming DRAM chips to prevent this kind of attack. Details on this attack can be found in this paper by the ETH Zurich, very nice paper, and this explains how this new attack works. So the last article is about CRDTs, about conflict-free replicated data types. It's the following article here, and it provides an overview over the basic principles and properties of CRDTs. CRDTs are a specialized set of data structures designed for collaborative applications where multiple users can simultaneously do local updates without requiring a central coordinator or a validation from other users. And over time, despite these independent updates, CRDTs guarantees that all users will eventually converge to a consistent and unified dataset. And this property makes them quite useful in developing applications, for example, Google Docs or Figma, but with real-time collaboration and without relying on a central server. So this can be in a peer-to-peer fashion. They can communicate these updates from one user to the other, not requiring a central coordinator. And this is the first article. There's a second article, this article here. This is more like how to build it. So here it's more about explanation. And in this article, the author shows how CRDTs work and also explain some data structures. So here is what is CRDTs, especially the properties. They have to be commutative, associative, and idempotent, meaning that it doesn't matter if the update is first update A, then update B, or update B, then update A. Also the order, if you have three kind of updates, it actually also doesn't matter, and update with itself also results in the same result. So these three properties are quite important for those algorithms, and the author explains here how last write wins with logical clocks. Here we can update things and we see that what's going on. It's quite nice. We can also simulate network which doesn't work. So we update here 2, 3, 4. Here on the right side I had the last write. So if the network comes up, actually the right hand side will then, if I enter 5, then the update will happen on the Alice's side. So this one is for the last write register. There is the last write wins map, which is also explained quite well. And what I like about this article, so you can also play with it and see what happens, increase the latency. And together with an actual implementation, you get a feeling of what CRDTs are and how they can be used. And as I mentioned, the next step, this is the second article here, which shows the full application, which is basically here a pixel board where two users can draw pixels that can increase the latency. And you see that on the other side, eventually this is being updated. I can set here the color, and this is reflected then here on the left hand side. Very good article. I recommend this to go through and take a look at it. So that's it from my side. See you next week.